Hello and welcome to Notes 1.8 for Pre-Calculus. Today we are going to look at composition functions, and you've probably seen this written before a little bit in Algebra 2 as f of g of x or g of f of x. And basically all we're doing is taking one function and plugging it into another. Just like you take a plug and put it into a wall so you can charge your phone, here we're going to take one and plug it into another. So let's look at what our functions are. They're defined for us right here. F of x is x squared plus 1. And I think color coding is a technique that works really well to help your eyes see what you're looking at. And we have g of x. So they're giving us two different functions, basically two rules. Okay. So this tells me that I'm going to add f of x and g of x. And notice what this is telling you is that if you could write it two different ways. You could say f of x plus g of x, or you can just put the f plus g of x. This is showing you two different ways to write it. And what I'll do is I'll go through and highlight my g's pink and my f's yellow, and that kind of helps me. I'm always in a hurry to get things done, and this takes my eye, and when I see yellow I know to look at that rule. So all this is saying is take f, which is x squared plus 1, and add it to g. You want to get in the habit of making sure you put your second function together. It doesn't really affect it when it's addition, but when you get to subtraction, we need to remember to distribute the minus sign. So I try to build a habit of putting parentheses around my second piece. So here we're just going to add like terms. The only thing that's like are the 1 and the negative 2, so we're going to end up with x squared plus 3x minus 1. And that is simply f plus g of x. And that tells them when you added two functions together, and that's what you got. Okay? It says to find the domain. We're going to practice what we learned yesterday. Remember, if this is a polynomial, what's the domain? This is a parabola, and what's the domain on all parabolas? Negative infinity to positive infinity. Remember, our domain is only going to change if we have a variable in the bottom, in the denominator, or if we have a variable under a square root sign. Otherwise, we're pretty much negative infinity to positive infinity. Again, I call these speed bumps. I'm going to slow myself down. If I hurry, I may subtract the wrong thing. This ties my eye so I know, look for the yellow one. There's the yellow one. So I have x squared plus 1 minus g of x. And what is g of x? 3x minus 2. If you forget to put the parentheses, what's going to happen is you're going to say minus 3x minus 2. The parentheses are going to remind you that you're subtracting a negative, so it's actually plus 2. So what we're looking at here is x squared plus 1 minus 3x plus 2. So what is our final? X squared minus 3x plus 3. Remember, we always write our polynomials in descending order. X squared comes before x, and then the constant is last. And this is f minus g of x. It doesn't matter whether you write it like this or like this. I prefer this one because I have to write less. What's the domain? Again, this is a parabola, so what's the domain on this? Negative infinity to positive infinity. Writing domains is a lot easier if you practice knowing what curves are. Okay, and what do we have going on here? What notation does that look like to you? There's your f function and g, and what does that dot mean? It means to multiply, so here we're multiplying those, so I'm going to write f, x squared plus 1 times g, 3x minus 2. And we know that we're going to have to FOIL those. So f times g of x is 3x. X squared times 3x is 3x cubed. Then we're going to have minus 2x squared plus 3x, and then minus 2. Again, this is a polynomial, and there's no denominator, there's no square root, so what's our domain going to be? Negative infinity to infinity. Okay, this one says to divide. All right, so f of x is on the top, g of x is on the bottom. Again, f of x, so f of g of x equals, put f on the top, x squared plus 1, 3x minus 2 on the bottom. Can we simplify? If you can simplify, go ahead. Nothing here simplifies, so it's finished. What is the domain? Well, we have a bottom, so we have to look at something we can't use. What number would turn this denominator into a 0? Well, you can set it equal to 0. If you see it with your eyes, that's okay. If you need to write it down and figure it out, that's okay too. So we would say x cannot equal 2/3. Now I'm going to write a number line down. You don't have to do that, but that's really going to help you see what the domain will look like. So if I put this here and I say, okay, there's 2/3, and I can't use it, it's an open circle. I can use any other number but 2/3, so I can use anything here, and I can use anything going this way forever, right, and put arrows on there. So how do I write that in interval notation? Well, this goes to the left, so I'm going to say negative infinity to 2/3, and it's a parenthesis because I can't use it, and or 2/3 to infinity. This lets us know that 2/3 is an excluded value. Okay, now we have composition of functions. F of g of x. What this means, and you can write it this way, or you can write it this way. I prefer to write it this way because I think I can write it a little faster. So we're going to say f of g of x is, what does this mean? It means you're going to take this function and plug it into that one. Or you can think of it as this function plugged into that one. So what I would do is write the first function down, which is x squared plus 1, but instead of putting an x down, put parentheses, open parentheses. Okay, so this is the f function, which is x squared plus 1, but we're plugging g into f. So instead of putting x in there, we're going to plug g in. And what is the equation for g? 3x minus 2. Okay, does that make sense? You've got your f function, which is right here. I took this one, and then I'm taking this and replacing it with x. That's why I would always write open parentheses, and that gives you a space to plug them in and helps you remember that something has to go there. You do have to finish that out. So what is 3x minus 2 squared? Remember, that is 3x minus 2 times 3x minus 2. You cannot just square each one. You actually have to FOIL it. So you're going to get 9x squared minus 12x minus 4. And of course we got that plus 1. Whoops, plus 4. That's negative 2. Yeah, sorry. Plus 4 plus 1. And so our final answer is 9x squared minus 12x plus 5. And what is our domain on this? Again, that's a parabola, so you already know the domain. Negative infinity to positive infinity. And let's compare the two. This one says plug g into f. Plug g into f. What is this one saying? This one is saying take function f and plug it into g. So what you're going to do, okay, I'm going to write down my g function, which is 3x minus 2. I'm going to go ahead and write that down because I want to emphasize the parentheses. Well, no, I don't want to do that. So I'm going to write down 3, and I'm going to leave an open space for the x because I'm not going to use the x. I'm going to put f in there. So what belongs in the parentheses? Well, your f function belongs in there. So that's x squared plus 1. And now you've finished that out here. We just have to distribute. So that's 3x squared plus 3 minus 2, which is 3x squared plus 1. Okay, what's the domain on that? Again, we have a parabola, so it's negative infinity to positive infinity. Okay, so here we work just with equations. We didn't evaluate them. Can we now evaluate and get some numerical values out? Well, this says f plus g of 2. There's two ways you can look at it. I'm going to show you both ways. You're not going to do it both ways. You're going to pick the way that you like the best. One thing I could do is that I can go up here and say, oh, I already added f plus g, so that's x squared plus 3x plus 1, and just plug 2 in. So that would be, you know, if you go back up right here to this equation and plug 2 in, 2 squared is 4, 2 times 3 is 6. So what does that give us? 9. The other way you could do it, if you hadn't already added these, just plug 2 into the first one. Okay, so if I plug 2 in right here, 2 squared is 4 plus 1 is 5. And then I'm adding, and I can take 2 and plug it into this. 3 times 2 is 6 minus 2 is 4. So either way you do it, you're going to get the correct answer if you use the one you manipulated or you use the original. Here's my thought on that. If I get to choose, I would always tend to do it this way, because if I take this number and I plug it into the original, there's not a mistake there already, and if something happened and I made a mistake and got this one wrong, it would make this one wrong. You have your choice. Couple different ways to look at it. I always go back to the original if I'm given the choice, so that if I made a mistake here, I don't compound and end up with a wrong answer on this one. Okay, this says g of f of 10. That means I'm going to find f of 10, and then I'm going to plug it into g. So let's find f of 10. So if you go up here, 10 squared is 100, plus 1 is 101. Now I'm supposed to find g of 101. And if you'll label your work like this, it'll help you remember that you plugged 101 in because you got that answer. So if you go over here to 101, this one's easy, so we're gonna do it in our head. What's 3 times 101? Well, that would be 303, and then minus the 2 because there's a minus 2 up here, so that's going to be 301. See, it sounded scary because it was a big number, but it's really not. F of g of 3, that means I want f on top, g on the bottom. So if I go over here, 3 squared is 9 plus 1 is 10. Then I plug 3 into g. 3 times 3 is 9, minus 2 is 7. Make sure it won't simplify. It does not, so we're good. And last but not least, f of g of 1. Remember, if it's written this way, it wants you to find g of 1 and then plug it into f. So you're going to find g of 1 first. And g of 1, 3 times 1 is 3, minus 2 is 1. So now you're going to take that 1, and I'm going to draw an arrow so you don't think it was this one that we plugged in. You take your answer and plug it in here. So if you plug 1 into f, 1 squared is 1, plus 1 is 2. So now we've looked at an algebraic manipulation. You have some algebra. Here's how we do it. What if I were to just give you a graph instead of an equation?